Hey, I'm back here. We're talking about biomolecules in class, and we need to get some perspective. See me? Hello. On what they are exactly. And we've studied atoms, and we've seen how atoms are kind of the building blocks of all matter, that they come together and they form different compounds, I can't see, really are the components of everything in the universe. And we'll get to eventually the fact that all living things, since this is biology, we want to talk about living things. We'll talk about the fact that all living things are in fact made of cells. But what we're talking about now kind of falls in between. It's atoms come together and form these biomolecules. And the biomolecules will actually link together and, well, not necessarily link, but they'll combine to form our living matter, cells, that is. And then, of course, cells forming all living creatures and organisms of every kind. So what biomolecules are really just collections of atoms. But more so, we're going to see that we need to build them up a certain way so that we kind of understand what they are and how they work and all that. They are hugely varied in terms of what they can produce, what kinds of ways they can come together. Now, there's four main groups here. And the four main groups are carbohydrate and protein and lipids, and probably a little less familiar sounding are the nucleic acids. And you're going to need to know each of them. You should know the groups and have a definite understanding of how they work. They each have their own characteristics. They each play a different role in our bodies. And that's really a big thing for me, is I want you to understand why it is you're supposed to eat certain things, and why things like a low-carb or a no-carb diet are really not that good for you. So we'll talk about that at some point. But each of these macromolecules they're big, so they're called macromolecules, have different functions, as we'll see. But there are themes as we put them together. You're going to see some themes, and that is actually the reason for my Lego scene here. I'm not just playing with my Star Wars characters, which I could have been. But there's a point here. Let me grab these guys, and let's talk about this a little bit. Now, Chewbacca, and I guess it's probably Luke Skywalker here, have nothing to do with macromolecules, although they would be composed of macromolecules. Oh, that was sad. My whole thing fell apart. But all of these components are actually what I wanted to get to. You're going to get confused at some point and see that our macromolecule, something like that looks so regular and very easy to understand. But if you can get this concept that this bigger block is composed of smaller blocks all linked together, there you go, then you'll understand macromolecules a little bit better. So let's look at this one. It's just a basic subunit. I'll pick this one because it'll show up a little bit better. It's just a basic subunit of my Lego tower that I had. And this would be made up of atoms. You know that, right? I mean, this is matter, and so it's made up of atoms. But it's come together to form this particular structure. It's got characteristics, and in this case it'd just be shape and stuff, although shape is important in molecules. A key thing is that if I can take a second one of these and bond it to it, well, now I have a new structure. I'm sort of building something. Now I have two of them. When I had one, there's a term that goes for it. We could kind of call this a mono-Lego, one Lego. And then this, the scientific way to say two, is di, D-I. And so now we have di-Lego. And then I could keep going, and technically I'd have tri-Lego and tetra-Lego and penta-Lego. But at some point you just say it's a poly-Lego structure that I have. And I could do that for any of these structures, even the one with Luke on it. And we're just building. And so keep that in mind as we go forward. The subunit we can use, there's a general term for it. It's called a monomer. And then the whole big unit is called a polymer. For most of the categories, 3 out of 4 of the categories, this is how it works. You have to figure out, well, what's the little unit, the subunit, the monomer, and how does it come together to form the big unit, which we would then call the polymer. Proteins, carbohydrates, and nucleic acids all are polymers of monomers bonded together, so subunits. Lipids are a little bit different. They kind of fall into what we call the odd sock drawer. They're just not carbohydrate, protein, or nucleic acid, so they are lipids. So keep that in mind as we go forward, that you're going to be looking for small units bonded to bigger units, and you want to get the structure down. You want to understand what the functions are, what they do, and then what they look like. With that in mind, you'll have a little bit of lesson on that right now, and then you'll explore each of the groups individually. All right, cool, bye.